The final step in understanding the simulation is to understand how the individual people or workplaces are now located at a certain cell, so how they choose their location. Therefore, we open the component C# _ grow and move. This opens this script. In the beginning, we define again a few variables. So the new work and new pop integer values means we distribute in each iteration 10 workplaces and 10 population units or 10 households. We have a random value that we will use later for our roulette wheel. And we have a list, the sum list, which is the sum of the values of my work distribution and population distribution lists. So here I put together the units of households and workplaces that I have in one cell. And this line of code is just an elegant way to sum up two lists or the individual values in each location of my list. So here I can make a sum of all the individual values. So value A of list A plus value A of list B. The next step, that's now the crucial part for finding the location where I want to place a new household, respectively later the workplaces. But before we do this, we check if the locations are already filled up. So that's my loop that I have here. I check every location, the population distribution count. This is to go through all my cells. And I ask if the values of households plus workplaces is above a certain threshold. That's what I've set here with the slider, the max density. That's 100 units in my case. If I'm bigger, I define that my cell is full, and to ensure that there will be no new household or workplace located there, I set the attractivity to 0. So it's not attractive at all for new inhabitants or new workplaces. And finally, as mentioned, I will distribute new households or new workplaces at the location. So I choose the location for a new household, for example, what's happening in this loop. Therefore, I use a so-called roulette wheel selection. And to illustrate this, I prepared, or I used a video from YouTube, which you can see in the background. So the roulette wheel, which you know, has individual slots, and I roll a ball, and this will end up in a slot of my roulette wheel. But in our case, we change the sizes of the roulette wheel so that slots, or in my case, the grid cells with a higher attractivity becomes bigger, and grid cells with a small attractivity, they are very small. And why I use this roulette wheel is to decide at which location some new unit will be located, and the probability now is higher that a new household selects area with a high attractivity, because that's a big slot in my roulette wheel, compared to the smaller slots. So the roulette wheel is implemented basically here. I do this for every place in my grid, and here I create a random value. That's here the random next double. This creates a random value between 0 and 1, and this is multiplied by the sum of all attractivity values to ensure that I cover all possible values in my roulette wheel. And then I go through all the individual values that I have in my attractivity landscape and the attractivity map for the population. So the attract pop holds, that's the list with all attractivity values. And then I just go through the values and make a temporary value and ask if the temporary value plus the new attractivity value, if this is bigger than my randomly generated value. And at the moment when it is bigger, I know I'm in a certain slot. And of course, small slots have a small probability to be chosen in this logic. And then I found my slot. I just store the index of my grid cell, that's K, and I break the whole loop because now I found my slot. I don't need to continue. Again, I check if my slot is not full, and I check if the slot is, the slot not equals to -1 checks if I really have found a valid slot. There could be some error in the script for some reason, but if not, I check if it's full, means if it's above the max density. If not, I will add a new household, which is done by adding the value 1 to my population distribution value. So that's the list that holds all individual households. That's the population distribution that I will return finally. I do the same thing for the workplaces, so I don't explain it because it's exactly the same, except that I use the attractivity for workplaces, and I increase the work distribution list if I place a new workplace. And finally, I just return the lists to the output variables of my component. The whole thing means that if you add a new land use, for example, let's say services, then you need to add a new block. So that's one block of code that I have here to make this location choice. So to decide which location to choose for your new land use per iteration and how many you will distribute. So then you run this for or as often as you want to distribute new units in an iteration. In my case, this was set to 10 for workplaces and 10 for new households. That's basically the idea of the location choice model or module in my whole simulation. As mentioned, this can be constant because you don't need to change anything here as long as you don't increase or if you don't add a new land use or something. Basically it's the land use. Then you have to increase this list and add the new code block. The basic control is how to generate the attractivity map.